Space is an amazing place, but one of the most interesting things about space is its extremes. Today, we're focusing on temperature, a fundamental aspect of our universe. Get ready to visit a scorching inferno and a frigid wasteland as we uncover the secrets of the hottest and coldest planets. In the grand celestial dance around our sun, two planets stand out for their extreme temperatures, Venus and Neptune. Venus, often called Earth's sister planet, boasts temperatures hot enough to melt lead. This makes it the hottest planet in our solar system, even hotter than Mercury. How can this be? The answer lies in the mysteries of its atmosphere. Neptune, a blue giant lurking in the distant reaches of our solar system, is a realm where the sun's warmth barely reaches. Neptune's temperatures plummet to levels that would freeze our blood, literally. Prepare to be amazed by the power of nature on a planetary scale. When it comes to planetary temperatures, distance from the sun plays a critical role. But it's not the only factor. Enter the power of the atmosphere, a planet's own personal blanket. This gaseous layer can either trap heat or let it escape, dramatically influencing a planet's climate. Venus experiences a runaway greenhouse effect. Its dense atmosphere, choked with carbon dioxide, traps heat with remarkable efficiency. Neptune, on the other hand, receives very little solar energy. This, coupled with its atmosphere's composition, leads to extremely low temperatures. These two planets showcase the fascinating interplay between distance and atmosphere in shaping a planet's temperature. Venus, the second planet from the Sun, is often called Earth's twin. But don't let that fool you. Venus is a planet of extremes, a scorching inferno that defies expectations. Its average surface temperature hovers around a staggering 867 degrees Fahrenheit, 464 degrees Celsius. Venus's atmosphere is about 90 times denser than Earth's, creating a crushing pressure on its surface. This thick atmosphere plays a crucial role in turning Venus into a planetary oven. The atmosphere of Venus is a hostile and unforgiving place. Composed primarily of carbon dioxide, it's a toxic cocktail that would be instantly deadly to humans. The real culprit behind Venus's extreme temperatures is the thick layer of clouds that permanently shroud the planet. These clouds are composed primarily of sulfuric acid, a highly corrosive substance. These sulfuric acid clouds are incredibly reflective, bouncing much of the sunlight that reaches Venus back into space. However, it's these very clouds that contribute to the runaway greenhouse effect that makes Venus so incredibly hot. The greenhouse effect is a natural process that occurs on many planets, including Earth. However, on Venus, this process has gone haywire, creating a runaway greenhouse effect. Sunlight penetrates Venus's atmosphere, reaching the surface. Some of this energy is absorbed by the planet's surface, warming it up. The warm surface then radiates heat back out toward space. But on Venus, the thick carbon dioxide atmosphere acts like a giant blanket, trapping the heat and preventing it from escaping. This trapped heat warms the planet further, creating a vicious cycle that continues to drive temperatures higher and higher. Venus stands as a stark reminder of the delicate balance of atmospheric processes and the extreme consequences when that balance is disrupted. Imagine a world where the sun never truly breaks through the thick clouds, casting a perpetual twilight across the landscape. The air is heavy, thick with the stench of sulfur, and the ground beneath your feet is hot enough to melt lead. This is Venus. Due to the extreme temperatures and crushing atmospheric pressure, exploring the surface of Venus is incredibly challenging. However, through robotic missions like NASA's Magellan spacecraft, we've caught glimpses of this alien world. Venus is a world of volcanoes, vast plains of solidified lava flows and towering mountains. The intense heat has baked the surface dry, leaving behind a desolate and unforgiving landscape. From the searing heat of Venus, we journey to the other extreme, to a realm of perpetual twilight and frigid temperatures. Here, in the distant reaches of our solar system, orbits Neptune, the eighth and farthest known planet from the Sun. Neptune is a giant of a world, a gas giant with a diameter nearly 4 times that of Earth. But unlike the gas giants Jupiter and Saturn, which are known for their swirling bands of colorful clouds, Neptune appears a serene, deep blue. At an average distance of 2.8 billion miles from the Sun, Neptune receives less than 1% of the sunlight that we enjoy on Earth. This incredible distance means that Neptune is a world gripped by an unrelenting chill, with temperatures plummeting to unimaginable lows. Neptune's extreme distance from the Sun is the primary driver of its frigid climate. Unlike Earth, which receives a constant and relatively intense bath of solar radiation, Neptune exists in a state of perpetual twilight. The Sun, from Neptune's perspective, appears as a small, dim star, providing only a fraction of the warmth that sustains life on our planet. To understand the impact of distance, imagine a campfire on a cold night. The closer you are to the fire, the more intense the heat you feel. Neptune, situated in the cold outer reaches of our solar system, receives a meager amount of solar energy, resulting in its incredibly low temperatures. Neptune's striking blue appearance is a direct result of its atmospheric composition. Unlike Earth's atmosphere, which is primarily composed of nitrogen and oxygen, Neptune's atmosphere is dominated by hydrogen, helium, and a trace amount of methane. It's this methane that gives Neptune its distinctive blue color. Methane absorbs red and infrared light from the Sun, reflecting blue light back into space. But Neptune's atmosphere is more than just a pretty face. It plays a crucial role in shaping the planet's weather and temperature. While Neptune's atmosphere does trap some heat from the Sun, it's not enough to offset the intense cold of its distant location. The trapped heat does, however, contribute to the dynamic weather patterns observed on Neptune. Despite its distance from the Sun and frigid temperatures, Neptune is far from a static and lifeless world. It boasts some of the most extreme weather in our solar system, with massive storms and supersonic winds whipping through its upper atmosphere. One of the most striking features observed on Neptune is the Great Dark Spot, a massive storm system similar in size to Earth. These storms on Neptune are thought to be fueled by the planet's internal heat, which is slowly radiating out from its core. This internal heat, combined with the trace amounts of methane and other hydrocarbons in its atmosphere, creates dynamic weather patterns that continue to fascinate astronomers. Beneath Neptune's turbulent atmosphere lies a mysterious and largely unexplored interior. Scientists believe that Neptune's core is composed of rock and ice, surrounded by a thick layer of metallic hydrogen. Neptune, with its deep blue atmosphere, raging storms, and mysterious interior, offers a glimpse into the incredible diversity and extremes that exist within our own solar system. In the grand cosmic theater of our solar system, Venus and Neptune take center stage as the epitome of temperature extremes. Venus, the scorching second rock from the Sun, stands as a testament to the power of the greenhouse effect. Its thick carbon dioxide-laden atmosphere traps heat with relentless efficiency, creating a surface hot enough to melt lead. Neptune, on the other hand, paints a vastly different picture. This icy giant, lurking in the distant reaches of our solar system, experiences the chilling grip of a distant sun. Its deep blue atmosphere, though surprisingly dynamic, cannot compensate for the lack of solar warmth, resulting in temperatures that plummet to unimaginable lows. These two planets, one a fiery furnace and the other a frigid wasteland, offer a glimpse into the extremes that nature can produce. The stark contrast between Venus and Neptune's temperatures can be largely attributed to their vastly different atmospheres. Venus's atmosphere, a dense shroud of carbon dioxide, acts like a giant heat trap, driving a runaway greenhouse effect that sends temperatures soaring. Imagine a car parked under the summer sun with its windows rolled up. The sunlight streams through the glass, heating the car's interior. The heat, trapped inside, has nowhere to escape, causing the temperature to rise rapidly. Neptune, in stark contrast, possesses an atmosphere that, while dynamically active with storms and high-speed winds, cannot overcome the extreme cold of its location. The trace amounts of methane in its atmosphere, while responsible for its stunning blue hue, do little to trap significant heat from the distant sun. These two planets, through their contrasting atmospheres, showcase the crucial role that this gaseous envelope plays in shaping a planet's climate and determining its fate. Section 3. Surface stories. From volcanic inferno to icy plains. Venus and Neptune have vastly different surface environments due to extreme temperature differences. Venus, with its runaway greenhouse effect, is a landscape of intense heat and volcanic activity. Imagine vast plains of solidified lava and towering volcanoes spewing molten rock. Neptune, in contrast, is an icy expanse beneath a thick atmosphere. Its surface is thought to be a frigid expanse of frozen gases. These planets highlight the dramatic impact of temperature on shaping environments. Section 4. Uniqueness in extremes. Lessons from Venus and Neptune. Though seemingly worlds apart, Venus and Neptune, in their extreme nature, offer valuable lessons about the diversity of planetary climates and the factors that contribute to their formation. Venus stands as a cautionary tale, a stark reminder of the delicate balance of atmospheric processes and the potential consequences of a runaway greenhouse effect. Its extreme temperatures serve as a stark reminder of the importance of understanding and protecting our own planet's delicate climate. Neptune, on the other hand, expands our understanding of planetary atmospheres and the challenges of supporting life in the cold, distant reaches of a star system. Its frigid temperatures and dynamic atmosphere provide valuable data points for scientists studying the formation and evolution of gas giants. These two planets, in their stark contrasts, highlight the incredible diversity of our solar system and the importance of studying these celestial bodies to gain a deeper understanding of planetary science, the potential for life beyond Earth, and the interconnectedness of our universe. They remind us that even in the most extreme environments, nature finds a way to create beauty and wonder. Planetary blueprints. Deciphering the language of extremes. The extreme temperatures of Venus and Neptune hold profound implications for planetary science. By studying these celestial outliers, we gain insights into planetary processes and climates. Venus, with its runaway greenhouse effect, highlights the balance of atmospheric processes. It underscores the role of greenhouse gases in regulating temperatures. Neptune expands our understanding of habitability in cold, outer star systems. Analyzing its atmosphere refines models of planetary formation and evolution. These extreme worlds provide essential data for understanding planetary dynamics and habitability. Beyond our solar system, the quest for life in a universe of extremes. The lessons learned from Venus and Neptune extend far beyond our own solar system. As astronomers discover thousands of exoplanets orbiting distant stars, the quest to identify potentially habitable worlds becomes increasingly important. The extreme environments of Venus and Neptune provide valuable benchmarks for characterizing these distant planets. When observing exoplanets, scientists often rely on limited data, such as size, mass, and distance from their host star. By comparing these characteristics to our own solar system's planets, including the extremes of Venus and Neptune, astronomers can make inferences about an exoplanet's potential habitability. For example, if an exoplanet is similar in size and mass to Venus and orbits very close to its star, it might suggest a Venus-like environment, potentially too hot to support life as we know it. Conversely, a Neptune-sized exoplanet located far from its star might indicate a frigid, gaseous world with limited potential for life. The study of Venus and Neptune, with their extreme temperatures and unique characteristics, provides a crucial framework for interpreting data from distant exoplanets, guiding scientists in the search for life beyond our solar system. Reflections on two extremes. Lessons in planetary diversity. As we conclude our exploration of Venus and Neptune, these two celestial bodies remind us of the incredible diversity within our cosmic backyard. From the scorching hellscape of Venus to the frigid depths of Neptune, our solar system showcases a remarkable range of environments. Venus, with its runaway greenhouse effect, serves as a cautionary tale, illustrating the delicate balance of atmospheric processes. Neptune, on the other hand, expands our understanding of planetary atmospheres and habitability. By studying these two extremes, we gain a deeper appreciation for the vast spectrum of planetary climates. The universe, a tapestry of extreme temperatures. Venus and Neptune represent just a small fraction of the thermal extremes in the cosmos. From the heat of exploding stars to the frigid depths of space, The universe is woven with extreme temperatures. As we venture further, we encounter even more extreme environments. Planets close to their stars may make Venus seem temperate. Rogue planets likely experience a chill surpassing Neptune's atmosphere. The universe is a place of awe-inspiring beauty and incredible power, captivating our imagination.